Under our techniques, you have algebra. So if you integrate a constant k, you get back kx plus c. If you integrate x power of n, you just increase the power by 1, divide by the new power. If you have ax plus b whole thing power n, you just the same thing, increase the power by 1, divide by the new power. Although you have to divide by the derivative inside the function. And these two functions only apply when n is not minus 1. So when n is minus 1, you get 1 over x and 1 over ax plus b, right? And therefore you get the ln function, ln x and ln ax plus b, though for ax plus b, it will also divide by the derivative of the function. If fx is purely algebraic, so let's say we want to integrate fx equal to dx, you just need to solve it term by term. So each algebraic term, you integrate it independently. But, if you need to, expand first. Under exponentials, if you were to integrate e to the power ax plus b, you get back the same e power ax plus b, but you must divide by the derivative inside the power. Under application, we first have a definite integral, so basically just the same integral but with upper limit b and lower limit a. So let's assume that if we integrate fx with respect to x, you'll get back gx plus c. If we put the limits inside to make it a definite integral, we just simply add the limits to gx, so we get back gb minus ga. Moving on to area between the curve and the x-axis. So let's say you have the cubic graph, right? And let's just consider the area A only, although the video says A to B. So A is bounded between x equals b to x equals c, right? So the area of A is simply b to c fx dx.